To best understand networking standards and concepts, we must first define a network. In its simplest form, a network is a group of interconnected devices. Take your home or office, for example. Several computers can often connect to a printer if one is present. The devices can communicate because they are on the same network. These same devices can, through a gateway, router, or similar means, connect to the internet, which, if you think about the definition of a network, is the world's largest network. At its foundation, the internet is a vast network consisting of groups of smaller networks, all with the ability to communicate with each other. The specifics of how they connect will be covered later. Networking uses models to move data from a source to a destination. The first model we will cover is the TCP/IP model, which consists of 4 layers: application, transport, internet, and network. The application layer is the top layer of the TCP/IP model, and it doesn't handle applications themselves, even though it is called the application layer. Instead, this layer defines how apps interact with a network. For example, a web browser is not part of the application layer. Still, the protocol it uses to interact with the internet, Hypertext Transfer Protocol, HTTP, is part of the application layer. The transport layer ensures a reliable data transfer from a source to a destination. Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, are the 2 main protocols used on this layer. Another topic will have an in-depth explanation of these 2 protocols and a comparison of the 2 protocols. The internet layer handles addressing, fragmenting, and routing data packets from source to destination, including one network router to another. Internet Protocol, IP, and Internet Control Message Protocol, ICMP, are important protocols on this layer. The network access layer, or the network layer, defines the data link and physical aspects of data traversing from a source to a destination. For example, wired and wireless connections such as Ethernet and Wi-Fi, respectively, are established to transmit data. How does this all work, you might ask? Take, for example, this Word document I want to send to someone. When this document is being sent to a destination, it does not look like this, as it is being sent. At the transport layer, this file is broken into numbered segments, like a shipment with multiple boxes numbered, 1 of 10, 2 of 10, and so forth. The data is broken down further into packets and addressed on the internet layer. This process is equivalent to boxes being labeled with an address. Then these packets are broken down further into frames on the physical layer. Then the frames are broken down into bits, 0s and 1s, and transmitted to their destination. The process is then reversed as data is made from bits into frames, frames into packets, packets into segments, and then back into the form in which the app service intended the file or files to be sent. Knowing networking models is important, as troubleshooting can start on a layer of a network model. For example, if a device is not receiving requested data, one can start at the bottom of the TCP/IP model and look to make sure the physical component of a network is working properly.